This is Bill Brayton, the Senior ATRA Senior Research Technician. This is the DPS6 Introduction webinar. Thank you all for taking the time out to attend. First of all, let's take care of the business. Connections, make sure you've got a solid connection. Hardwired internet works best. Wi-Fi can break down and lose connection, and that's not a good thing. So be sure you're hardwired to the internet. The handout, most of you, all of you should have the handout by now. If you do not, send an email straight away to webinars@atra.com and we'll get that out to you immediately. If you have any questions, feel free to write it down in the text box, in the question box, and we'll get it answered as best we can. If we don't, I'll figure out the answer and I will send you out an email. At the end of the show, you'll receive a survey. Please take the time to fill out the survey and let us know how we did. Today's presentation is sponsored by Seal Aftermarket Products, your source for engineered solutions. Now we have a short video.
Seal Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing PPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
Alrighty then, and also we'd like to thank our co-sponsors, Whatever It Takes Transmission Parts, and my favorite publication, Gears Magazine, for the transmission rebuilding industry. If you have any questions or comments, please contact Lance Wiggins at ATRA. That's lwiggins@atra.com. Here's our overview of our webinar schedule. Lots of dates, lots of great information coming your way, so be sure and catch all the dates in your area. I should say in your time zone. Okay, it's never too early to start planning for Expo. This year it's going to be expanded to 4 days, the 29th through the 1st in October there at the Rio Hotel and Casino, same place it was last year. We've got an expanded tech program, management program, and the showroom floor is going to be as big as I've seen it in many years, so it's going to be a great show. And also special for this year, in your local area, the Saturday seminars that travel to your area, one lucky attendee will win a free expo package. That's a complete conference registration, the tech, the management, the trade show, and we're going to put you up for 4 nights at the Rio. Not only is the tech a great incentive to go to the Saturday seminar, but if you're looking forward to going to Vegas, you could be the lucky one to win that free package at your local show. Pretty cool stuff. Okay, so let's get into applications. Mainly here in the States, the DPS6 is available in the 2011 and 2015 Fiesta and the 12 through 15 Focus. Australia and the UK has the EcoSport and the B-Max and the C-Max. The C-Max and the B-Max are available, I believe, in the UK and South America only. So we're going to focus on the Focus and Fiesta. So moving right along, this transmission is pretty cool because in Ford's terminology, it operates without interruption of propulsive force. Unlike previous stick shifts where we push in the clutch, interruption of power flow, change gears and resume power flow. This works, the dual clutch system works without that interruption. There's two input shafts. There's two input shafts, a solid and a hollow shaft. This is built, there's two output shafts. So basically it's it's actually two transmissions inside of one housing. They use the Focus and the Fiesta use dry clutches that are electromechanically controlled. The computer decides when to apply which clutch when. And lastly, the gear shift mechanism now, it's external, but it only controls the parking pole in this unit. We'll see that in just a little bit. It's a front-wheel drive transmission. Obviously, it's got a two-part housing, 6-speed, dry clutch with travel-controlled wear adjustment. Now I'll be explaining that a little bit later on. It's a pretty cool setup. And a two-part input shaft, I already said, the hollow and the solid, and the two different output shafts. And it's all electromechanically actuated, both the clutch and the gear shift systems. Some of the common sounds that come out of this thing are common sounds that we hear out of most stick shifts. You could have clicking noises when we're upshifting and downshifting, whining noises, because after all it is a stick shift, slight gear whine, totally normal. Clicking sounds after the thing is turned off. The computer cycles the clutches to the neutral position so that the vehicle can be restarted in a neutral position. And we might even feel some noises during trailer hitching events, which is considered normal. I mean, it's a stick shift after all. Some of the other characteristics, reverse gear whine, that's common in pretty much all stick shifts, even though they're helical cut gears. And you might even have some clutch break-in noises. These clutches have a break-in period and also a relearn period that you will get maybe a rattle noise or some upshift and downshift noises that will diminish as the clutch breaks in. Which is interesting because, you know, I don't ever recall clutches really changing feel after a while, but when it's computer controlled, I don't know. I guess it is. Also, a little history I looked up on the internet about this unit and the dual clutch setup. It was first invented by a Frenchman in 1939, but it was never developed at that time because he couldn't afford the working model, and there weren't computers yet. So it took until 1983 that Porsche developed a system with a computer small enough to fit in two models that they ran at Le Mans and won. So that was breaking it into its first automotive applications. And the first production car was the 2003 VW Golf. Now almost there's quite a few manufacturers that are going to this, and if you've ever watched a F1 race, the F1 cars have been using these for quite some time. Okay, so that's a little bit of history. Here's the external components. We've got the two clutch actuator motors, the TCM, the output shaft speed sensors, 1 and 2, and then the OSS. Here's our MLP. And then finally, here's the shift lever. As I said, it controls the park pawl mechanism. Now here's the legend for the previous picture. Notice it says clutch actuator 1. Down here it says clutch actuator motor 2. Okay, this works the clutch that is affected, that is operable in 2nd, 4th, and 6th, as well as reverse. Motor 1 handles the shaft that works 1st, 3rd, and 5th gears. We'll be taking a look at power flow in just a second. Here's the TCM bolted to the, on the left is bolted to the unit. On the right, here we've got it unbolted and flipped over, and you can see the business end of these brushless motors. You can see the clock gears in here. They're called clock gears. I'll show you that, a better picture of that in just one moment. And here's an illustration of the exploded view of the TCM, the circuit boards, and the brushless motors. I tried to take this one apart. You see it has some screws here, here, and here, but the seal at this plug was a little too tough, so I just included an illustration. And here's a look at the internals, the clock gears that run the shift forks. The combined gear ratio of these gears is 61.44 to 1. That means that for every 66 turns of the motor, the shift drum will rotate once. Okay, so what that does is that provides up to 330 plus pounds of shifting force. That's quite a bit, and that's how they get the shifts to happen swiftly and smoothly. Oh, here we have, also I wanted to point out, we've got the hollow shaft. That's a good look at the hollow shaft and the inner core shaft, or the solid shaft, and the two output shafts. We can see them engaged to the final drive. Here's the park pawl mechanism that I was talking about, because once this thing, you get ready to turn the car off, you engage it into park, and the clutches go to neutral. There we go. Here's a breakdown, a cutaway view of the dual clutch components. Okay, here we can see clutch 1 spline to the core or solid shaft, clutch 2 spline to the outer hollow shaft, and here we have the engaging bearings. Okay, these are engaging bearings. This is number 2 and this is number 1. They are controlled by these motors that move these plates that engage the clutch. See, what they do is, and I'll show you in a minute, is they're not, this is not the throw-out bearing that we grew up with. This is now an apply bearing, and this is how it works. On the left, we can see the air gap here. It's difficult, but we can see it when compared to the right side. And the roller is in the up position when now in this, on the left side, the clutch 2 is released and 1 is applied. Now this would be the driving shaft. Now as the computer wants to engage this clutch, it spins the motor, and this screws down the roller, pushes on the lever, which in turn pushes on the engaging bearing. And because the fulcrum is right here, it pushes the plate from right to left so that it applies the clutch. So it's completely backwards from the clutches that we've come to know and love over the years that we've changed so many times. So this is now applying the clutch. The clutch is applied and driving instead of releasing and changing a gear. Here's a look at the guts of the clutch actuator motor, the brushless actuator motor. Now, the main differences besides the brushes, is that on a brush type motor, the windings, you could see them here inside the housing, were part of the stator, and the magnets were in the housing. But what that did was it limited the rotation, and the brushes created too much electromagnetic interference just by their very nature. So what the engineers did was they turned the motor inside out and put the windings in the housing and the magnets on the stator. Now the computer can control clockwise or counterclockwise movement, and through these 3 Hall effect sensors we see here, can tell the direction and count the RPMs of the motor. These motors can run between 1 and 3,000 RPMs. So these guys can spin up pretty good. Here's the clutch I talked about, the self-adjusting mechanism. I thought this was pretty cool because the clutch discs that the traditional clutch discs, I should say, been around for so long. Well, those clutch discs that we're used to, the pressure plates, I should say, when the disc wears, when the friction disc wears, the height of the fingers changed. So back when we had a linkish type clutch pedal, we had a screw rod, and we had to take up the adjustment until it was at its proper gap or its proper level, and you know, we'd have to do that to make up for the wear of the clutch. Then came along the hydraulic circuits and the hydraulic release bearings, and the hydraulics took up that wear through the piston travel. Well, the engineers decided that, and the computer guys decided that they want this distance right here to be set, that this roller will only go up and down a certain amount always. So they had to figure out how to make an automatic self-adjusting pressure plate. And how they do that, I'm not going to read through the whole text on the left side of the page. You guys can take a moment to do that. But basically what happens is, through the clutching process, as it wears, it creates an air gap, and this red ring is spring loaded, and as the friction disc wears, it will, and the air gap is created, it turns and keeps the finger, turns and makes up for that wear. It's a really ingenious setup, and yeah, I think it's pretty trick. Okay. Excuse me. Here we're going to go through power flow of these units. Here we have the various gears on both the shafts. We've got reverse, fourth, and third on one shaft, and then 2, 6, 5th, and then finally first. So this is a 4-speed transmission here on this shaft, and a 3-speed over on this shaft. So This is, and for this illustration, the differential is only attached to one, but it really is, as we saw, attached to both. So here we have first gear, and I want to add that over here on the right of the picture, I've written in the ratios. That is not in your handout, so feel free to write that in. Just a kind of bit of an FYI. Now, here we have it in first gear. So the computer knows that we're through the various sensors that we're in acceleration mode. Through the TPS, the mass airflow sensor, all the load sensors know that we're going through a throttle up condition. Well, what the computer can do is take this. So in this illustration, these shift sliders are not going to be moving. They're not going to be moving, but so when we shift gears, this one's going to be over the dogs here, and this one already is, and we're in first gear. So as it sees that we're going up in speed, it can slide this collar over so that when it goes to second gear, all it's doing is changing from one friction plate to the next. So through the whole upshift process, this is second gear with the 2.429 ratio, is that this can be in the shifted position and this can be at the shifted position at the same time. But why doesn't it bind up? Because every stick shift that I've ever built, if it was in 2 gears at once, you better be holding onto your seatbelt, right? Because it would stop the car. Because there are 2 different input shafts, the pink, the longer line, and the hollow shaft. Allow those 2 gears to be shifted in the same at the same time. Now, we're in second gear. We're going to go ahead and the computer's going to move the shift collar, and it goes back onto the pink shaft, and as it will do this whole process as it goes up through all the way into 6th gear, because it can anticipate, it knows that we're going into an upshift mode, and we can switch gears that much faster. And technically there should be no shift feel at all when it transitioned the gears. I took a drive last week at the Ford dealership in one of these things, and it still had a little bit of a shift feel that I believe the computer programmers put into this so that people are used to having a shift feel. They want to feel it shift, and so I believe they built that into it. But technically speaking, when it goes from one clutch to the next, there's 4th gear back onto the blue shaft. As it goes from one gear to the next, there shouldn't be any shift feel at all. So this going from clutch to clutch. Here we are in 5th gear back on the pink shaft. And then finally 6th gear at 0.07. I went through that kind of fast right here. Let's go back through that so you guys can get, if you're writing down the ratios. Here's second at 2.429. There's third at 1.436. And fourth, 1.02. We never get a 1-to-1 on this unit. And now we have 5th gear, 2 overdrive ratios, 0.867 in 5th, and then finally 0.702 in 6th gear. And last but not least, in power flow is reverse. So this is fixed. The reverse gear is fixed to second and works with the gear over here reverse. And here's the mechanism that makes it all happen. You could see the shift forks. This are calved into the drum. When the drum turns, it raises and lowers the shift fork. This particular fork goes all the way across and is working back over here on this synchronizer. This drum works up over here, and this fork connects over here and works this synchronizer assembly way back in there. And the last one is over here, which works the lower synchro over here. And that's what allows it to get those gears and get them so fast. We haven't seen a lot of wear problems. One guy asked me, this looks like a metal tab and an aluminum drum. We haven't seen wear in this area. One of the things we have seen go wrong are these bearings are starting to fail. You can get these bearings. The parts, I spoke with an engineer in Detroit. He said that at this moment, the parts that are replaceable are just the shafts. The synchros are not yet available separate. So if you have synchro concerns with these things, which to date I have yet to see, but I have heard of these bearings failing. The engineer says that the individual parts should be available, I think he said sometime next year. Okay, so here are the inputs on the left. We've got an ABS, we've got an ECM, we've got a body control module. Here's our shifter, our speed sensors, shaft 1, shaft 2, and our OSS. Here's our MLP. And now our motors are on the both sides here. Well, that's because of the Hall effect sensors in both of the clutch motors and the Hall effect sensors in the shifting motors. These 4 motors make the whole thing happen. Here's the legend for the previous picture. It explains all the items in the previous picture. I wanted it to be larger, so not set it real tiny, so that's why we put it on 2 different pages. And lastly, this is the number one issue with these units right now is these black seals are failing on 100% of the Ford Focuses and the Fiestas out there. So if you see one of these leaking like this, these are the culprits. This seal, and there's another seal inside of here. You can see the ramps and the engaging bearing mechanisms have been removed here to get at this seal. This seal is pretty straightforward to replace. However, you need the special tool. There's a seal that's down in there, about 1.5 inches, sealing up this the solid shaft with the hollow shaft. Now, the special tool that you're going to need is basically a larger version of a GM manual lever puller. And that pulls it right out real nice and easy. Well, we've got to have the seal protector sleeve here. It protects the sleeve from, protects the seal from the splines. And this driver tool. This has a ledge on it right here to gauge exactly how deep that inner seal is going to be. Should you get that seal out, you don't use this tool in the way this is sitting, you could get it either in too far or not far enough, and this seal won't last but 1,000 miles and it'll self-destruct. So it's very important to have the special tools. Okay. We'd like to thank you guys for coming. Thanks, Mike Marvalis and Hank Blair. Good to see you guys out there. And I'd also like to thank our sponsors. If you guys have any questions, Now's the time to type them in while I take care of the finishing business. I'd like to thank WIT, Whatever It Takes Transmission Parts, and my favorite publication, Gears Magazine, for the transmission rebuilding industry. And our title sponsor, Seal Aftermarket Products, your source for engineered solutions. Engineered solutions. And let's see, if there are no further questions, my name is Bill Brayton. Thank you for attending. Enjoy the rest of your lunch hour and make it a great day.